In this video, I'm going to review the problems from example 5 that you were asked to do, where you were asked to find the least common multiple.
Now, one of the reasons that the least common multiple and greatest common factor, greatest common divisor, which we did in the previous example, oftentimes get confused is that they both start off the very same way. So if I want to find the least common multiple, the LCM of 18 and 24, I'm going to get their prime factorizations. So now I'm not going to go through it as much step by step in this one because the factor trees could look a little different, but as long as you produce the exact same prime factorization, you're good. So 18 can be split into 2 times 3 squared. 24 can be split into 2 cubed times 3. Now here's the difference, and here's where some of the confusion comes in. When we did the greatest common divisor, we would go through and see which numbers they had in common and what essentially the smallest power of each one they had. So if I was looking for the GCD of this, I would look at 2 and 2 cubed, and I would choose 2. And look at 24 and see 3 squared and 3, I would choose 3 and say that the greatest common divisor is 6 between these two. When I do the least common multiple, I'm going to be looking for the highest power of these numbers that they have in common. And if they don't have a number, if there's a number they don't have in common, I'm going to include that too. So they both have 2's being multiplied. This one has more of them. So 2 cubed is going to be one of the things I'm going to use for my LCM. And 3 squared is going to be the same. So my LCM is going to be 2 cubed times 3 squared, which is 8 times 9, which is 72. So that's the smallest number that both of these numbers can be factors of. Let's move on to the next one. The LCM of 120 and 360. So again, I'm going to start with doing the prime factorizations of these. And so 120, you see my factor tree there. I broke it down, and it becomes 2 to the third power times 3 times 5. And 360 becomes 2 to the third power times 3 squared times 5. Now, as you can see here, as you probably could also figure out, that 120 does go into 360 evenly. And I can see that evidence for that here. I mean, because if I look at the highest powers of the bases I have in here, 2 cubed is in both of these, so I'm going to take 2 cubed. 3 and 3 squared, well, 3 squared, I'm going to take that. And 5 and 5, well, I'm going to take the 5 because they both have it in common. So all of the numbers that that I'm going to be using are the parts of 360. And therefore, when I do my LCM, it's just going to be 360. And this stands to reason again because 120 is a factor of 360. So, sometimes the number you have out there one of those numbers can be the least common multiple. It's just like the same thing. If you have two numbers, one of the numbers could be the greatest common factor as well. Moving on to the next one. The least common multiple of 45 and 60. So again, prime factorization. The 45 can become 3 squared times 5. 60 can become 2 squared times 3 times 5. So when I compare the numbers, this one has a 2 squared, this one doesn't have a 2, so I'm going to take the 2 squared. This one has a 3 squared, this one only has a 3 to the first power, so I'm going to take the 3 squared. And they both have the multiplication of 5, so times 5 is going to be part of the LCM as well. So those are the numbers I'm going to take. So the LCM is 2 squared times 3 squared times 5, which ends up being 180. On to the next one. Again, I'm going to start with the prime factorizations. 87 is 3 times 29. 111 is 3 times 37. And 3, 29, and 37 are prime numbers. So now I'm going to look at these two numbers and see, what I need to do to come up with the least common multiple. So they both have a 3, so 3 to the first power is going to be part of it. This one has a 29, so 29 is going to be part of the LCM. This one has a 37, and that's going to be part of the LCM. So when I look at those numbers, multiply them together, I get 3219. A lot of students sometimes just make the mistake of just going right to the point of just multiplying the two numbers together. And although that would be a multiple of those two numbers, remember we're looking for the least common multiple. So the fact that they had the shared 3, if I had multiplied these two together, I would essentially have 3 times this number down here as the answer. And obviously that's not the least common multiple. It's a common multiple, but not the least one. So some of my lines are showing already on this one. So the LCM of 21 and 110. So there are their prime factorizations. And as you can see here, they don't really have any numbers in common. They don't have any prime factors in common. This was a 3 times 7. This doesn't have any of that. This is a 2 times 5 times 11. This doesn't have any of that. So this is one of those instances where the least common multiple would be the result of me multiplying these two numbers together. Because you can see all parts of 21 are being multiplied, all parts of 110 are being multiplied eventually. And there should be a dot here for multiplication, but you get 2310, and that's what the answer is for this. So sometimes the least common multiple is the result of multiplying those two numbers together, but it's not always going to be the case. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.